Okay, this is to clarify some questions for the lab. I know that some students are going to have some trouble. I know this from experience. Alright, so I'm going to go through a couple of these things and try to clarify some questions that I see are going to come up. So as you're looking at the screen, you're going to see this. Okay, you're going to have the velocity as the ball leaves the ramp will only be in the x direction. And I'm going to find that from Vx equals delta x divided by delta t. Delta x is right here down at the bottom, which you should have in your data. And then delta t, you're going to be calculating it twice. In this case, you're going to use the t that you measured by hand with the stopwatch. Okay, so that's what you're going to do with this one and the first one. You're going to do this for all three distances, for 0.5, 0.75, and 1.0 meters. You're going to do it for all three of those. Okay, you should have three different delta x's for that. For the second one, you're going to find the theoretical time. In that case, same exact calculation, except the delta t is going to come from the calculated value, which we expect to be a more reliable value, which comes from this equation. Delta t equals the square root of 2 delta y over g, or the acceleration of gravity. Okay, you have to be a little bit careful here, though, as some of you have already seen. Gravity is, so let me give you an example. Gravity is in meters per second. Meters per second squared. The delta y, most of you have measured in centimeters. Centimeters and meters don't mix well. So this number has to be, this delta y has to be put in as meters. So I think most of you have a number that's something like 97 centimeters, 96 centimeters. That has to be 0.97 centimeters. And then divide that by 9.8, and that will give you the time. For this, you're going to do the same thing. You have to determine the velocity for 0.5, 0.75, and 1.0 meters. Okay. Your delta x again comes from this delta x, not from the 0.5. That's the starting position. Okay, the delta x is down here, what you measured on the floor. All right. Oh, I'm sorry. I already did both step 2 and step 3 in the same place. So step 2, officially, you're supposed to just find the time. Step 3, you're going to put it into the calculation. That shouldn't be that terribly difficult. For here, write a statement comparing the two different velocities. Basically, you can just say something about they're different. We expect, maybe you say, we expect the value measured by hand to include a lot of error, and the calculated value to be more accurate. Okay, nothing too complicated. And then you have your data. Everything on there should be clear. You should know how to make a data table. The next part here where it says evaluation, 2 sources of error and ways that you can improve that. So there's 4 points there. Okay, make sure you list the 2 sources of error and how you can improve them. Again, a calculator error is not an acceptable source of error. Okay, just like crashing your car into a tree because you're not paying attention is not a problem with the car. That's a problem with you. Okay, 2 major sources of error you can, some major sources of error you can think about: the timer, you can look at the distances, any type of measurement at all is a good source of error. You can also look at any way that the lab is set up, the way that the ramp is set up, the way that the angle is calculated. All of these kinds of things will include some error. Okay, if you don't calculate the angle correctly, like you use sine instead of cosine, that is not a lab error. That's a user error. That's your problem. Okay. For the final conclusion here, I changed this slightly just to be clear what you need to do. You should state which ramp has the highest horizontal velocity, what that velocity is. So I added that there. Again, this is where your conclusion must have a number. It must have data. Okay? In this case, which ramp has the highest horizontal velocity? It should be 1.0 meters. And what is that velocity? You should list it, whatever your number is that you come up with. 1.2 meters per second, or 150 centimeters per second. Whatever it is that your value is, that has to be listed here. And then the one last thing, which frequently scientists are asked to do, and students, is to come up with another experiment you could do with a different variable. Maybe that variable could be, to give you some examples, that could be the height of the table, could be the size of the ball, the mass of the ball. It could be the angle of the track. It could be longer lengths of track. It could be even something more complicated, like instead of using a ball, it could be using a wheel. It could be with a cart. Could be a number of different things in there. It could even be that it's launched at an angle instead of launched horizontally. So write a statement about that, complete sentences. Okay, that's how lab reports are done. Okay, and then be clear that you check your final completed lab to make sure that you have everything here. You have your all the points here. You can see this is a 23-point lab, so it's a larger lab than we usually do. I also, I did change this. It used to say include the following in a new Word document. I don't want you to use a Word document. I want you to just do the whole thing in OneNote. Okay, just to be clear. I expect this to be finished by next class. I will probably take a look at it to see if you have had any major errors. If you have major problems, try to come and see me. If there are still continuing major problems with your lab, I will be inclined to accept it late if you talk to me. Okay? Alright, have a good weekend, and I will see you soon. Bye.